Guys, welcome back, and if you're new to my channel, thanks for joining me today. Today I want to cover off HPE's Nimble Performance policies. So why do we have them? What do we use them for? And what attributes are associated with them? So let's jump straight into it. I'm just going to fire up my browser, enter the IP address of the actual array. Now, as I've saved my credentials and logged into this array before, it automatically logs me in. I'm now going to head over to Manage and Performance Policies. Now, before I start talking about the details of performance policies, just a bit of a trip down memory lane. So back in the day, we used to install hard disks into arrays, and we used to basically, once installed additional capacity into them arrays, we used to have to basically carve up them disks into a block size, and we used to typically carve them up into 512K. Now you may ask, why 512K? So applications write at different block sizes, and that's variant depending on the application. And we went with 512K on the basis that every application would fit into the 512K block. So we wouldn't get any fragmentation of application writes down to the array. However, that wasn't the most space efficient way of doing it, because you would, let's say you write with an application down to that block with an 8K application, then 8Ks worth of data would be written down to the block, and the rest of the data of the 512K block in this example would be wasted. So we're not that efficient. However, that did stop read and write amplification, generating further traffic and further reads and writes across the SAN infrastructure. Now, you might say, well, why not do 4K block, and therefore you are a lot more capacity efficient? Well, yes, because we are writing then in 4K blocks. However, if an application is writing down in 8K, then effectively we have to write that to 2 blocks. So we then become not as efficient, because we might have write amplification and read amplification. When an application goes to read a block, we now have to read from 2 blocks, and we may induce further latency across that infrastructure stack because of that. So yes, we become space efficient, but we now have amplification and fragmentation. So again, not a great scenario. So HPE Nimble Storage have addressed this with what they're calling performance policies, and they're basically working on a platform that has variable block. So all applications write down to the array in whatever block size that application is defined to write down in, and the actual storage array ingests all that and stores it efficiently without fragmentation. So we get the best of both worlds. And how do we do that? Well, we basically have performance policies, and we associate them performance policies with a volume, and the volume is associated with an application that writes or reads at said block size. So that's how we go about it. So just to give you an example of that, let's take Exchange 2010 data stores, and as you would expect, it's associated with MS Exchange Server application category, and we are defining a 32K block size. So we have a couple of other attributes that sit around that. Compression, and in this case it's enabled. So what that means is every write that's written down to the array, we basically do inline compression and compress that data further to get better space savings. So, which is nice. Then we have caching, and in this case it's enabled. As it's a hybrid array, we have this functionality of caching. And what that means is we write data down to the hard drive layer, we basically coalesce it, compress it, and then write it down to the actual hard drive layer where we've got triple parity data protection. And the caching, if this is enabled, what that means, if deemed as cache worthy, we will put a copy of that data in SSD. So obviously SSD as a technology is a lower latency technology over hard drives, and therefore when reading back data, that read cache has a low latency, so we get a better user experience, we get a better end-to-end stack latency, so just all round better user experience and performance from the application. So the last option that's associated with performance policies is the quarter exceed behavior, and we have two options. In this case it's set offline, so for every volume that's created we create a volume quarter, which by the way by default is set at 100%. So that means when the volume is a full effect, if left at the default 100%, what do we do? So in this case the volume would be set offline, so it protects that data. However, no more reads or writes can be read from that or written to that volume associated with that performance policy. The other option, as you will see on a different one, is set to non-writable. So what does that mean? If we were to set it as non-writable, what that means is the volume becomes read only. So we can now read, but we can't write down to that volume. And the one last thing really about, by the way guys, I haven't created any of these performance policies. These are all available out of the box. There are a couple of things to note with these though. For example, if I put a tick in a box here, it highlights these two options to either edit or delete the performance policy. Now, performance policies cannot be edited or deleted, as I will demonstrate. So as you can see, you just get error messages whichever option you select. So what happens if you get an application that isn't an off-the-shelf application? What do you do? How do you go about that? Well, you have the plus option here, so you have the option to add a new performance policy. So I'm just going to call this test in this demo, but you will create a name for that performance policy that would be associated with volumes that are associated with the application that are meaningful. So in this case I'll call it test. It's not an off-the-shelf application, so therefore I'm going to select other as an application category. The block size I'm going to say for this demo is 32K from that drop down box. Then we have compression, as I talked about. Now, when would you turn that off? Now, if you've got an application that is pre-compressed, then you wouldn't burn array CPU cycles to try and compress something that is already pre-compressed. Now, obviously, depending on the algorithm, you may get some slight savings on that. You might actually make it worse if you've got already a strong algorithm that compresses really well already. You might actually lose space savings from that, so just bear that in mind. that you would be burning CPU cycles to try and compress something that is already pre-compressed. In this case, I'll just leave it on for the demo and then caching. Are we going to put a copy of that data in SSD? And we would do that if it's likely to be read back. Now, when wouldn't you do that? Well, typically if you are writing backups down to the array, and it's a backup array, would you cache that in SSD? Typically not, because hopefully you would do, well, typically you would do lots of writes down to the array, and you would only read back on the option, on the need to restore data. Now, for the majority, you would be writing down to the array, so in that case I would turn caching off, but in this case I'll just leave it on for demo purposes. And then quota exceeded behavior I'm going to set to non-writable, and I'm going to click create, and as you can see here it says successfully created the performance policy test. So if I scroll down in this list, I should now come across an option that says, I don't initially see that, test, there. Bit blind today, clearly. So I've got the performance policy test. I've got no associated volumes with it at the moment, and as you can see, the attributes that we've just gone over are now shown here. So let's say I want to amend that. Again, it's just put the tick in the box, now highlights these options, but because this isn't a predefined performance policy, I can now delete or edit it. So I'm just going to click on edit, and there is a caveat. So you can basically change anything in the performance policy from an attribute point of view, other than the block size. If you need to change the block size, you have to create a new performance policy, a new volume, and then migrate that data over, because everything in the array is done in line, and you want to re-ingest that data into the new volume with the new performance policy. And something we haven't talked about in this video, but you've also got deduplication. So if you want to, again, because it's in line, if you want to ingest that to deduplicate the data, you would have to basically migrate volumes. So yeah, so just bear that in mind. As you can see, we can change out anything, but the drop down is now missing for the actual block size. So I'm just going to change that to test 1 for the purposes of this demo, and click save. And as you can see now, it's called test 1, and the tick for compression and caching I've took out of it, and as you can see, it's changed to now disabled. So that's it, guys. I hope that's been helpful, and if you like the video, as always, please like and subscribe. Many thanks.